For years, one company dominated artificial intelligence hardware. If you wanted to train large language models, if you wanted cutting-edge inference performance, if you wanted serious AI compute, you went to NVIDIA. Their GPUs became the backbone of the AI revolution. From OpenAI to Anthropic to Meta, NVIDIA hardware powered it all. But behind the scenes, Google was building something different. Not a GPU, not a modified gaming chip, but a purpose-built AI accelerator designed from the ground up for machine learning. And now, Google has unveiled its most powerful AI chip ever, Ironwood, the 7th-generation tensor processing unit. And this isn't just another chip launch. This is Google signaling something much bigger. They are no longer just building AI models. They are building the infrastructure of the AI era. Ironwood is Google's latest TPU, tensor processing unit. It is the 7th generation in a lineage that began quietly in 2016 when Google first revealed that it had been using custom AI chips inside its data centers for years. Unlike GPUs, which were originally designed for graphics rendering and gaming, TPUs are built specifically for neural networks. They are optimized for matrix multiplication, tensor operations, low-precision compute, AI inference scaling. Ironwood is designed primarily for inference at massive scale. That distinction matters. Training large AI models is expensive and computationally intense, but once a model is trained, the real challenge becomes serving it, answering billions of user queries efficiently and cheaply. Ironwood is Google's solution to this problem. It is built to deliver more performance per watt than GPU alternatives. That could mean cheaper AI at scale, and that changes everything. Unlike general-purpose GPUs, Ironwood is an ASIC, an application-specific integrated circuit. That means it is designed for one thing: neural networks. It eliminates unnecessary graphics logic. It prioritizes high-bandwidth memory, custom interconnects, AI-specific data pathways, tensor math acceleration. Each chip integrates massive HBM memory to reduce bottlenecks. Memory bandwidth is critical for AI workloads. Many AI accelerators are compute-rich but memory-constrained. Ironwood attempts to balance both. And then comes networking. Inside a superpod, thousands of chips must communicate with ultra-low latency. Google built high-speed interconnects to ensure the cluster behaves like one giant brain. This is not just hardware, it's a distributed AI supercomputer. Let's address the obvious. Is Ironwood meant to replace NVIDIA? Yes and no. Google still uses GPUs in some workflows, but strategically, Ironwood gives Google independence. NVIDIA currently controls a massive share of AI accelerator supply. That creates risks, supply chain bottlenecks, price dependency, competitive exposure. By building its own chips, Google controls cost, controls availability, controls optimization, controls roadmap. And here's the key. If Google's TPUs match or outperform NVIDIA in inference workloads, it reduces NVIDIA's leverage. That's not just a hardware shift. That's a power shift. Ironwood is not just about performance, it's about ecosystem control. Google Cloud can now offer AI compute powered by Google Silicon, AI models trained and served on Google hardware, full-stack AI optimization. This vertical integration matters. It's similar to what Apple does with custom silicon, custom operating systems, hardware, software, co-design. Google is applying that strategy to AI infrastructure, and it gives them something powerful: efficiency. When hardware and software are built together, optimization compounds. Reports suggest Google is supplying massive TPU capacity to AI partners. That includes companies building frontier AI models. Why does that matter? Because if major AI labs train and serve models on Google TPUs, Google Cloud becomes sticky, migration costs increase, and ecosystem dependence grows. It's no longer just about chips, it's about long-term AI infrastructure dominance. AI compute consumes enormous electricity. Data centers are becoming energy-intensive at unprecedented levels. Inference efficiency is now a geopolitical issue. Governments worry about power grid strain, carbon footprint, and infrastructure sustainability. If Ironwood delivers higher performance per watt, it becomes not just economically attractive, but politically strategic. Energy efficiency could determine which cloud providers scale sustainably. Ironwood is the 7th generation. That means Google has iterated through TPU v1, v2, v3, v4, v5, v6, now v7. Each generation improved compute density, memory capacity, networking, and energy efficiency. The trajectory suggests something clear. Google is not experimenting anymore. They are industrializing AI hardware. The AI race is no longer just about models, it's about chips, supply chains, data centers, power infrastructure, and sovereign compute. The companies that control hardware control AI capability. NVIDIA dominates GPUs, but Google controls search, YouTube, Android, cloud, and DeepMind. Add custom silicon to that list, and suddenly, Google becomes vertically integrated across the entire AI stack. That's powerful. For enterprises using Google Cloud, Ironwood means faster AI inference, lower costs at scale, more predictable pricing, and reduced GPU shortages. Companies deploying AI assistants, co-pilots, and analytics systems will benefit from high-throughput clusters, scalable inference, and integrated AI services. Ironwood strengthens Google's cloud competitiveness against AWS, Microsoft Azure, and that's a multi-trillion-dollar market. If Google continues scaling TPUs, NVIDIA's dominance could narrow. Custom silicon becomes standard, hyperscalers reduce GPU reliance, and AI costs drop. And when AI costs drop, adoption explodes. Lower compute costs mean more startups, more AI apps, more experimentation, faster innovation cycles. Ironwood may not be flashy. What makes this moment different isn't just that Google unveiled another TPU, it's that the pace of AI hardware evolution is no longer incremental, it's exponential. We are watching the collapse of traditional computing cycles in real time. 5 years ago, upgrading meant slightly better performance per watt. Today, it means entire architectural philosophies being replaced. Ironwood isn't just a chip, it represents a shift towards AI-native infrastructure. Instead of building hardware that can run AI, companies are now building hardware designed exclusively around AI workloads. That distinction changes everything. For decades, CPUs were kings. Then GPUs rose as the champions of parallel computing. But now, we're entering a third era, domain-specific accelerators built for neural networks at massive scale. And what's fascinating is how quietly this revolution is happening. Most people don't see the data centers. They don't see the racks filled with custom silicon. They only see ChatGPT answering faster. They see image models generating in seconds. They see AI video improving. But behind every one of those experiences is a hardware war being fought in silence. Ironwood represents a philosophical pivot. Instead of optimizing only for raw compute, the focus has shifted towards efficiency at hyperscale. When AI models reach trillions of parameters, the bottleneck isn't just processing power. It's memory bandwidth, interconnect speed, energy efficiency, and thermal management. That's where next-gen TPUs aim to dominate. Not just faster, but smarter in how they move data. In modern AI, moving data is often more expensive than computing it, but it could quietly reshape AI economics. The first phase of AI was about models. The second phase was about applications. The third phase is about infrastructure. Ironwood represents that shift. It's not about headlines, it's about control. Control over compute, control over cost, control over scale. The AI revolution isn't slowing down, it's industrializing, and Google just made its move. Ironwood is not just another TPU, it's a statement. The AI future will be built on custom silicon, and Google intends to power it. That's it. If you like this breakdown, make sure to subscribe to the channel. Catch you in the next one.